Welcome everyone to Taming the Chaos, how to turn unstructured data into decisions. Today, I have the pleasure of being joined by both Sienna and Sinai as our presenters for today's webinar content. And I'll pass things over to Sienna to kick off our introductions.
Hi, I'm Sienna. I'm a solutions specialist here at Safe Software. I've been here for around 7 years. I'll pass it off to Sinai.
Hi, everyone. My name is Sinai. I'm also a solution specialist, and I've been at SAFE for about 5 years now.
Excellent. Thank you both. So just a quick intro to our Livestorm platform if you are newer. So if you have any audio or video issues during the webinar, we have that help button on the bottom left for 4 simple steps you can take to troubleshoot. Share your emoji reactions with us on the bottom middle. That fuels our energy as we go along. We love to see those, how you're feeling and reacting to the content today. We have the polls tab. Great, everyone's already testing out the reactions. The polls tab. So we do have a couple polls coming up shortly, so keep an eye out for those. And questions. We do have Chris Berger, a part of our team, joining us on the back end today to support us with answering questions. Thank you, Chris. And then we'll also have time dedicated at the end for live questions. So do get those in as we go along. Don't be shy. We're happy to help with any of those. And keep letting us know where you're tuning in from in the chat. If you'd like to download the slides, you can either click that download button on the top right of the PDF or under apps and handouts. All right, so with that, I will prompt our presenters if we can turn off our webcams just to save on some bandwidth for the remainder here. And I'll take us through a quick snapshot of our agenda for today. So to kick us off, Sienna will be taking us through an intro to what is unstructured data and why it matters, followed by basics of prompt engineering for FME. And then our third segment will include a use case and a demo on summarizing documents. Actually, you're all in for a treat today. This is a more demo-heavy webinar, so you'll be seeing lots showcased live here. And then we'll be going through auto-extracting and organizing info, as well as using OpenAI to create embeddings. Last but not least, image metadata extraction and geotagging before we will wrap things up with a summary, resources, and next steps to help you leverage what you learned today. And then we will also have time, just to note again, for live Q&A at the end. All right, so with that, I will pass things over to Sienna.
Thanks, Elizabeth. All right, so just to kind of set the playing field, when we're talking about unstructured data, we're not talking about a small part of your organization. We're talking about a lot of data that resides everywhere. So back in 2019, the IDC predicted by 2025, we'd have about 175 zettabytes of data globally. So a huge amount of data. And about 80% of that data would be unstructured. So 80% of the data in the world, the IDC predicted, would be totally unstructured. And before AI, unstructured data was so painful to automate and to work with in a meaningful way that didn't require a lot of human intervention. But now we're seeing vast improvements to that thanks to AI. Well, let's set the playing field anymore. Again, what is unstructured data and why does it matter? Unstructured data is any data without a predefined format. So whether you're looking at text, images, PDFs, even a sticky note on your desk, that's all unstructured data. And it's really hard to work with when you're talking about an automated setting. It's hard to query, organize, visualize this data without a lot of transformation. And it's found all over. So in your emails, in your reports, field photos, customer forms. And often this data holds a lot of critical information that's hidden in plain sight because it's hard for us to extract this data, because there's just so much of it, that information is really hard to work with. So first, let's go into a poll. So what's your main goal of extracting information from unstructured data?
Yeah, and I did make the poll so you can select a couple if a couple stand out to you. I'll give everyone a moment there to let us know. Okay, it looks like we have most votes now. Yeah, if the team wants to head over to the polls tab, we can take a look at that together. It looks like actually pretty well split, with the top two being organize and structure information for easier access and automate repetitive tasks.
All right, should I move on to the next slide?
Yeah, thanks everyone for letting us know.
Yeah. And then how often do you work with unstructured data in your day-to-day tasks is the next poll. So we just opened that one up. So that one should be at the top right now.
Yeah, I'm curious to see.
It's pretty split. The top two are sometimes a few times a month and often a part of my regular workload, with 40% and around 30% respectively.
Yeah. Awesome. So yeah, this webinar should be quite helpful for, I guess, everyone, no matter what category you fall into there.
Yeah. And I would say unstructured data is just such a part of our day-to-day lives in so many ways, that no matter what, you should see why this is valuable to try to analyze this data. So why is unstructured data a headache? Manual processing is so slow and so error prone. It often takes someone who's a subject matter expert to scan through these documents to fully understand them. You might have things like shorthand notes. Like if I'm taking notes for myself, I might be able to understand it, but if I hand it to Sinai, she might not be able to. We might be using different language, different vocabulary. It's really hard to process this data because it's so inconsistent, because it's so non-standard, and it is incomplete. So it makes it really difficult to search, filter, analyze this data easily. So it's a high amount of effort to scan through this data and understand it, unless it can be automated. So what FME enables, and I should say FME combined with AI, because a lot of this workflow we couldn't do before AI. I once had someone ask me, they had directories and directories of files, and they had no idea what those files were. And they were like, can we use FME to scan through all these files? And could you tell me what's in them? And before AI, the answer was basically no. Like we could kind of look for key searches, keywords, but it would be really, really hard for us to tell you exactly what's in all of these files without using something like AI to intelligently tell you and give you a proper summary. But now, since we have AI, we can do this, and we can do things like power semantic searches, create great dashboards, and maps from these raw inputs thanks to AI. And Snai will be showing off a semantic search example later on in the webinar. So stay tuned for that. It's really exciting. If you're not familiar with FME, we have 3 different products. So we have FME Forum. That's basically where we're living in this webinar today. So FME Forum allows you to build these workflows and transformations to help you understand your data. Once you're ready to promote FME Forum and allow those workflows to work automatically, then we can publish those workspaces up to FME Flow. And this is how you automate your workflows and have them run in response to a source like a file arriving in S3 or a new email arriving. Those can kick off automations which allow you to process your data. After that, we also have FME Realize, which is an app you can use to look at your 3D data in the real world. What makes FME special? Well, it's our unrivaled data support. So no matter what you're trying to connect to, we can basically connect to it, even if it's a complex format like CAD, 3D, BIM, XML, raster data. We can process a lot of different data types. So let's talk about the basics of prompt engineering for FME. So prompt engineering for FME is going to look slightly different than prompt engineering when you're having a conversation with ChatGPT. And when you're working with ChatGPT, normally you would have a conversation back and forth and you would refine your prompt and you could extract information from it from something like a paragraph. But in FME, you can't really do that because this is all going to be automated later on. So, what you really want is a clear and specific prompt. The more context that you can provide the model, the better off you'll be. You'll want to use role based prompts. So, having a specific role to help, again, set expectations for the model. So, in this case, I said, you are a document classification assistant. You're going to get different results if you use that rather than if you say you're a financial analyst or you're a product marketer. These roles help define or help put into words what you're expecting the model to do. And that makes your results much clearer down the line. You'll also want to use a structured output wherever possible. So you want to define JSON for the AI to return. So you can process that JSON down the line into attributes, and then you're taking that unstructured data and you're making it into very structured data with that JSON. Enumerate the options, so have fixed categories as much as possible. Give it a set of choices to choose from so it can present to you the correct category so you know what you're expecting from your data. And then finally, I like to ask for justification. So give me a confidence score. How confident are you in your answer? And that allows me to audit later on so I can see how confident the AI is. So maybe I can look at the ones that AI is not confident in. But basically, a lot of this will be trial and error. You want the most consistent responses possible. So you'll have to go in, try it out once with a subsection of data, see how it does, and then refine it from there. And we'll see examples of that in one of the demos in the webinar. So what's a bad prompt? Well, I put a bad prompt next to a bad AI image here, and it would be something like classify this text. You're not defining structure or context. You're not giving it a role or output format. You're not giving it categories or justifications. So your output from that will be just as hard to process as the unstructured data was to begin with. Where something like a better prompt would be something that's role-based. You're defining a very specific task for it to use. You're setting expectations on what you want for the output. So here, select a category. Give me an explanation and give me a confidence score. You're enumerating the options. So you really want that fixed list for consistency. And then it's auditable because you can go back, look at its explanation, look at its confidence score, and maybe audit the ones that it's less confident in and look at the reasoning too. All right, so here is the demo portion of our webinar. Before I wanted to get started, I just wanted to say, we are using, I believe, the OpenAI connector for most of these slides that we're going through today. However, we don't just have the OpenAI connector. We also have Amazon Bedrock, Google Gemini, and many more different AIs available on the FME Hub. So take a look there, see if we're connecting to the AI you want us to connect to. And if we're not, just let us know. We'd be happy to take a look and maybe show off how we could connect to that AI in the future. Also, if you have a local LLM model, we can connect to that too. So if you're not sure what an LLM model is, it's like a local model that you can use typically through an HTTP caller, so your data stays local, reducing any security concerns. So let's look at the first use case. So this one is extracting insights from unstructured documents. So I'm looking at a very large PDF document here. This is a financial report by Nike for 2024. It's over 100 pages long, and I'll show how FME can analyze it. So instead of having someone go through and manually summarize this content, we're going to have AI look at it as well. And then we can integrate the results from this into something like Excel, databases, dashboards, or alerting tools for use later down the line. So first, I'm starting with the OpenAI connector. So using the OpenAI connector, there's an action called a file search. What this does is it, behind the scenes, so you don't have to actually do this yourself, but it uploads your file to a vector store. It uses that file for its next request to analyze the data, and then it will delete that file later on. The OpenAI connector is just a custom transformer that lives on FME Hub. So you could potentially go in and modify this connector to have it work for you. Let's say you want to do 2 queries based on the data provided. You could potentially go in and update that custom transformer so that it works for your organization. You can use bits and pieces from it, so it's totally editable. So for models, by default, it uses GPT-5 now, but you can use 4.0 as well. You'll see that it has instructions and a user prompt. The instructions provide persistent guidance that sets the assistant's behavior, style, or goals. And then the user prompt is a specific question that you want to be addressed. In my head, I kind of look at the instructions as like an umbrella that sits over the specific user prompt. So if you're asking lots of just different questions, but with the same set of instructions, that's kind of when you want to use the instruction user prompt model. In my case, I'm just asking one thing. So I'm just put that all in the user prompt. And then I'm setting the structured output in JSON. So I have a defined schema for later on. So what's my goal here? I want to automate getting key insights and structured data from this big report. Often valuable insights remain hidden in these large, messy files. So I'm using AI and FME to do this. And now I can process this data in minutes instead of hours. Oh, sorry. Do you mind starting the demo, Elizabeth? Thank you. Okay, so let's take a look what I have here. This is the OpenAI connector. And as you can see, I have my file to upload. This is coming directly from my desktop. And I have my structured output here. So again, this is just my JSON that I'm expecting the GPT to return to me. I also have a low temperature setting, and I'll talk about that in the next slide. So I'm going to go ahead and run this workflow. And what this is doing is it's uploading that very large 100-page file to OpenAI. So it does take a little bit to get this going, but I'll fast forward here and show you what the results look like and walk you through them. So first I have my JSON flattening. Because we're returning JSON, we'll have to work with our JSON transformers to flatten that into attributes. However, the JSON flattening is quite easy to do with FME, especially when you're working with OpenAI, because you often won't have any nested JSON. You'll just have straight up attributes to flatten. So it typically takes 1 to 2 transformers to do that. So there it is. That's all my JSON flattened into attributes. So you can see some things there, like cash at the end of the year is $9.86 billion, which is an amount I cannot imagine. After there, we're going to do some basic string manipulation. So I had some quotations and some curly brackets I wanted to strip. So I'm just doing that in these transformers. You could potentially do this all in one transformer. using something like the attribute manager and the string functions. However, just to make it really easy to understand, I decided to do it in 3 of our built-in string transformers, but there's many ways to do things within FME. And then, oh, this is just showing it stripped. The next thing I'm doing is I'm pivoting my data. So by default, FME assumes that you're working with many features or many rows of data. And then you want to have basically a very wide but short table. Well, when working with things like Excel, oftentimes you want a very long but skinny table. So I'm just kind of tilting that data on its side and manipulating it here. So my first step is I'm using the attribute manager and I'm just changing all those attribute names to make it more clear. And then I'm using my attribute keeper to only keep the attributes that I want to flip. And now I'm using the attribute exposer. And what this does is it basically blows up my table. So now instead of having that long, that wide but short table, now it's going to be tall and skinny. And that allows me to better analyze this data in Excel. I'm removing any FME attributes because I don't care about those anymore. I'm renaming those columns. So now instead of all of those ones, I have my metric and my value. So I can see per metric, these are the values that I have. And this could potentially allow me to compare how Nike is doing year after year. So I could run this with the 2025 financial report or the 2023 financial report and really build up a good table so I can understand it in Excel better. And this is just me writing this out to Excel. And I can see my results directly within FME as well. All right, I think I'm okay to move on, Elizabeth. Thank you. Okay, so lessons learned here. Because I was working with such a large file, I had to change the advanced settings in the OpenAI connector. So I was just increasing my timeouts to make sure I wasn't hitting my request limits. And I did take a look at the temperature setting. So I changed the temperature setting to a lower value because I wanted my output to be more predictable and consistent. I didn't want it to be random, varied, or creative in my output. So I just lowered those values too. And like I had before on the beginning slide, this is all in a article that's available online, so you can walk through this yourself. All right, next I'm going back to the example that someone gave me before, but before AI, we couldn't answer it, which was how to auto-instruct and organize key info from unstructured docs. So here I'm using the file and directory path names reader. I'm looking at a folder which contains 1,000 PDF files, and I have no idea what's in those PDF files. Now I'm going to pass that information and all those files to the OpenAI connector, and I'm going to see, can this categorize these files for me, and can it extract some key insights from the file? Finally, I send this to a file copy writer. So I'm going to move these files to a new location and give them a proper name. So here I'm classifying 1,000 files, and without automation, a significant time or effort, I'll use FME to do that for me. And now I'll have some organized files. All right, back to the demo. Okay, I ran this ahead of time because this would be really boring to watch FME process. In this case, I'm looking at 100 files, but not 1,000. So I had 1,000 files, and these 1,000 files were originally used to train AIs. So they are completely random and do not make any sense what they are. I have no idea what these files actually contain. So I'm using a sampler as my first transformer to go through. I'm just pointing out that the file names are basically nothing. The first file name is 0000, a lot of zeros, 1, right? So I don't know what these are. I'm passing this to my OpenAI connector, and this is what I'm getting from my results. So I can see I'm classifying the document, in this case, this is a legal document, is pretty confident with its score at 0.98. I have some keywords, so I could search these files later using some keywords. I'm having it give me a justification, a file name for what this should be called, and a language that the document is actually in. Again, first step, just use the JSON flattener, extract that JSON and put that into attributes. And this is an example of an explanation of the document and another one. Sometimes it doesn't know, so there is an other category as well. And this is just me pointing out the keywords that could be used later. Next, I'm using the tester here. So I'm looking for the English language and a classification that is not other here. So anything that's in English and actually has a category works. And then from here, I asked it to give me a proper file name. So this is the file name it came up with. And so I'll be using that to rename the files later. And then I'm moving that using the file copywriter. So if you've never used the file copywriter before, just think of it, instead of being a normal writer, it mostly just moves and renames your files. So I'm moving this to categorized PDFs, which will be a folder, and giving it a new file name based on what ChatGPT gave to me. So if I open this up, that's what it looks like. So I have 10 files in here, and I can take a look at one of these files. So this was categorized as English, but you can see in here it's a mix of English and German. And then if I wanted to, I could also have like an Excel file as kind of a way to see what these files actually were. And so I could reference that later on and see whether or not these files were useful. Elizabeth, would you mind going back to the slides? Thank you. So lessons learned here. You might have noticed that this prompt wasn't the best prompt, and I would have to refine this if I was actually using this in production. So the language classification, sometimes it would produce something like EN, English in all capitals, or English in lowercase. What I'd want to do is give it a subsection of languages to choose from. If I only care about English, I would just have it say, classify this as English or other, and then give it a clear way to present that to me, because it's much easier to filter out things when you know the values ahead of time. Also, I'm not sure if anyone noticed this, but the files names it was giving me, sometimes it would be .json. So I would ask them to produce a file without an extension name so that I could use that later on in my workflow more easily. And with that, I'll pass it off to Snai.
Fantastic. Thanks, Sienna. Next, we're going to jump into embeddings. So it's difficult to get meaningful search results from any data set, let alone unstructured text. Even for experts, valuable context can get missed when you don't have the exact search terms on hand. So in an ideal world, we'd have this ability to ask questions to our data sets in plain language and get all the relevant results back. So what we're asking for is semantic search. And semantic search doesn't just match words and keywords, it understands meaning. It enables us to spot unusual entries, group related issues together, and lets you ask language questions in plain language. So FME can bring semantic search into the same toolbox that we're already using for filtering, transforming, and connecting data, and turn messy text into something searchable and useful. So let's go over a few definitions for this type of workflow. Embeddings are the foundation of semantic search. So AI services convert freeform text into numbers that represent meaning. And there's different models available for embeddings, and all of those are different. So some are faster and cheaper, others are more accurate, some are optimized for shorter text, others for long documents or even code. These embeddings are stored in a vector database where we can run plain language searches. And the search itself isn't AI, it's just math on vectors, which means that this workflow is pretty achievable with the tools you might already have on hand It has relatively low overhead to build, and it can be confined to your own systems if you want. So in this demo, we're going to take an unstructured Word document that has lots of free-form maintenance notes. There's tons of useful information inside, but it's hard to search or analyze beyond just a keyword search with Control F. So the goal is to make these notes searchable by meaning and not just keywords. And we're going to use FME with an embedding model and a Postgres database. And in the end, you'll see how we can do simple queries on this data set, this Word document in plain language, and return a list of relevant results. So let's jump in. Okay, so we start with this Microsoft Word document. Everybody has seen these, worked with these. Everybody knows a word table. It's unstructured, it's hard to get information out of, but it's common, it's everywhere. So likely we're going to encounter these somewhere. We have a new Microsoft Word reader, and we can actually pull all of this information into the workspace using just a couple of transformers. So I expose the table, and then we have those attributes in the workspace, just a couple of transformers. So that's exciting. But moving on, we're going to turn the notes and a couple other attributes in this table into a sentence. And this is what we're going to feed into our embedding model. So we have some context around the notes, so we can easily identify what they're associated with. We're going to feed that embedding into our OpenAI connector. We have a new action here for embeddings. We'll give it our sentence, and we'll choose a small model for this demo. We have 1,000 entries, so I want it to be quick and fast. We'll do a couple of retries just in case something goes wrong. So once we run it through, we'll have 1,000 embeddings alongside some of our other attributes. And that's what they look like, just big arrays of numbers. And then we want to load that into Postgres. So this was the tricky part because FME actually doesn't have a vector type in Postgres, but native support has never stopped anywhere. Where there's a will, there's a way. So I used a select statement here with a cast to load it in as JSON and cast it to vector data on the Postgres side. And once I'm done, we just delete that JSON data. So it's a clean table. And that worked really well. So we can verify that the data was loaded into Postgres by doing a couple follow-up queries on a sample. We can see our JSON column is empty, our vector column is filled. And then let's run a similarity index, compare them to himself, and -1 basically means that it's great. Everything looks good in our database. So let's go over to DB Beaver and just view our table that we've just created. You can see our raw embeddings is empty, and our vector column has all of these arrays of numbers, which we are expecting to see. We can even take a look at the metadata of this table, take a look at our embedding column, and we can see that vector data type, which means everything went well. And we can now use this database for vector searches. So in our next part of the workflow, we're going to do just that. But to recap, let's just go over what we did before moving on. So in this demo, we used FME's new Microsoft Word reader to bring our notes straight from the Word document into the workspace. Once we did that, every note with some other attributes was converted into an embedding using OpenAI. Here, we could have just as easily used a local model like Ollama if we wanted to keep everything within our own network. Either way, we create these embeddings and then we store them in a vector-friendly database. And in this case, we use Postgres with PG Vector extension on it, which of course, open source, is free, takes just a minute to set up. Since FME doesn't have the Postgres vector data type available to write to, all we did to work around that was store the data as JSON and use SQL to cast it into vectors. And this was really performant. When you offload the processing to the database, you usually get very good results in terms of performance as well. So not too much of a sacrifice there. So in the second part of the demo, we're going to see how we can use FME to query this data so we can see what we've built and why it's useful. Okay, so this is our workspace for querying the Postgres database. And we have one user parameter to enter in a semantic query. Pipes showing early signs of rust or metal decay will be our example. So we'll run that in our workflow. We can run this live because one embedding is a lot faster than 1,000. And here we're just doing the same pattern. We're choosing the same model as well. We want to keep the models consistent. Once you've committed to it, that's your model. And here we get our embedding back, that big array. And now we're going to use SQL to query the Postgres database with this embedding by executing another similarity search, but this time comparing our query embedding to the embeddings that are already in our vector table. And this is a similar pattern of casting that JSON embedding to vector first, then committing the query. Then we will check our results with another similarity search. And we can see now we get a list of results with different search numbers, not just -1. These are ranking how similar they are to the results. And in these results, we can see words like rust, rusting, corrosion, metal decay, anything that might be related to our first initial query, even if it's not exact. So this is the type of workflow that can be accessible to a lot of people. You don't need to know SQL. You don't need to know databases. You don't need to know FME. You just know there's some notes in a Word document. So we can really easily make this into a flow app to make it self-serve, because that's our goal, to make these types of workflows accessible to everyone and to use AI or LLM to make that possible. So we'll create a flow app, maintenance logs, searcher, anything like that. Choose our workspace. We'll just have the one parameter for search terms. We could refine that a bit more if we wanted more detail, but that's all we really need. So let's try a different query. We're going to look for minor leaks with low pressure impact. Just pipeline type queries. And here we can see slow leak, leaking, leakage, pressure loss, minimal line pressure loss. All of these are ranked by their similarity. They're all related, even if they're not using our exact search terms. So we could look for anything that we could have, be in our embedding notes, like shutdowns that happened around the holidays, or maybe we want to throw in some weather data. We can associate different events with different weather events. Any type of query can be connected to a vector style search, and you can query those in plain language. So let's recap how that worked. We start with our plain language query, and we turn that into an embedding. And it's important to use the same embedding model to query the database that you use to build the database. That part matters. And then we have a similarity index that we create just using SQL to give us a ranked list of the most relevant results. And what makes this powerful is that semantic search doesn't just return the exact results, it finds results that are related in meaning, even if the original words don't appear in the query. Most importantly, this search itself isn't powered by AI. It's just a vector similarity search in SQL. That means it's fast, it's lightweight, and it keeps sensitive data private while still delivering something that feels like AI level insights. So you just have to use it in that first part to create that embedding. And you can choose whatever embedding model you prefer. So while creating this workflow, I learned a couple things. I learned a lot of things, actually. But one of them is to clean up your text before creating the embeddings. Just like everything else, good data will make better results, and you'll be happier for it after the fact. And of course, the quality of your results will also depend on the model. Use samples of your data first while you're building and refining these types of workspaces. This will save you a lot of processing power and potentially AI tokens and keep things moving fast. It's not the fastest process to create the embeddings in the first place. So definitely, if you're doing this locally, keep that in mind when you're picking your hardware. Pick the right embedding model for your process, balance your cost, your speed, your accuracy, and then stick to it, keep it consistent. Embedding models will sometimes automatically normalize vectors for you, others will not. So that will determine the type of similarity search you use. So keep that in mind if you're rebuilding this type of workflow based on this. Your SQL might look a little different depending on your embedding model. And another thing you can do to improve performance is to consider your FME architecture. Put FME next to the database for best performance. That doesn't just apply in this case, it applies in all cases. So look at your deployment, think about how you want processes to run, where they should run. And then lastly, always think outside of the box. FME can be extended in all sorts of ways. Even though we don't have support for vector data types yet, our support for SQL easily filled that gap. So this approach would work for lots of different scenarios. Some that I could think of off the top of my head were customer chats, research papers, legal documents, product descriptions, even captions or media. Basically, if it's text, you can embed it and make it searchable. So tell us what kind of data you'd like to embed in the chat, or if you have a vector database in mind that you'd like to see FME support, tell us that too. There's a ton out there now. Pinecone comes to mind, but there's many more. Postgres with PG vector extension. Go ahead and tell us, and we'd love to know. Okay, so next we're going to move on to our final demo. This is going to look at metadata extraction because it's particularly important for unstructured data, I think anyways. This is because unstructured files often appear to have little or no schema, which means little context at face value. It's a mystery we have to solve. So most of them actually do contain metadata that is structured in some way, albeit harder to read. We have timestamps, GPS, authors, device, projection. The problem is these are all hidden inside of the file. So we're going to look at making the most of this type of metadata. And all FME readers actually do bring available metadata into the workspace when it's there. They're just usually stored as hidden attributes. So they're not stored in the data inspector, but instead in the record information window. And we're able to expose these attributes so that they are visible and usable in the workspace. And then we can use that metadata to inform the rest of the workflow. Because metadata gives us this opportunity to cross-check what's been reported against what we believe to be true. And on this slide, this is a typical Survey 123 app that might be open to the public to report something like a code violation. And in this case, the survey was submitted in December 2024, but the photo attached to it might say something different. The metadata says that it was taken halfway across the world back in July 2020. So right away, when we make this comparison, the discrepancy raises doubts about the accuracy of the survey itself. And if we can spot mismatches like this early and do it at scale, we can build far more trustworthy data sets in the end. So we're going to start with a similar app in Survey 123, where the public can submit code violations with attachments. And not all the reports are going to be accurate. Some might contain mistakes. Some might have device mistakes. Others might be made in bad faith. You never know with this kind of thing. But in the end, this might cause field crews to end up chasing false leads, wasted time in the office, chasing down people. So we want to use FME to extract the hidden EXIF metadata from the photo and compare that to the survey information. So we'll check things like the photo time versus the report time, the geotag versus the reported address, and the image content versus the violation described. And from this, we'll calculate a confidence score that ranks reliability. We hope that this allows workers to respond faster, and the city can track survey quality at scale, maybe adjust things down the line to have more effective community outreach. So let's jump into this demo. So we start at our survey in Survey 123. Citizens can enter an address, but they can also maybe move this map pin around. And they'll also upload a photo, which has its own geotag. So that already gives us 3 locations for one report. They might give us some information in the comments. Our goal is to compare all of the survey data and the photo metadata to see if they align. So we'll start with the feature service reader, our new feature service reader, to bring in all these survey records. And from that, we'll use the ArcGIS attachment connector. We're going to download all the JPEGs to a local directory. And then once we have those, we'll read them in using the feature reader with JPEG. And if you click one of these JPEGs with the record information window open, you can see all of this rich metadata, everything from the type of phone used to the time, lots and lots of information in here. So we'll perform 3 calculations starting with location. And we'll geocode the reported address and create a distance calculation between the reported address and the photo. Then we'll move on to a date time analysis. And this will be the difference from when the photo was taken and when the survey was submitted. And from this, we'll create a second confidence calculation. Finally, we'll do a little lightweight image analysis using an LLM, because why not? This time we're using a local LLM, Llama, and we've got a prompt here that creates a confidence calculation based on some criteria we fed it. And we'll also do a structured output with this prompt so that we have these usable attributes. And one of the things that we've created with all this information is some context notes for the field workers to use when they're following up on this report. Finally, we have a weighted confidence calculation based on the 3 criteria. We'll throw these into buckets that are a little friendlier for everyone to glance at: low, medium, high. And then, because I couldn't help myself, we have our new PDF writer, which we will create 3 reports based on low, medium, high confidence. Our first one here is high. We've got pretty good timing, pretty good difference in distance. The image analysis didn't go so well for the LLM, so we've got it low there, but it's weighted. And then we have some notes here why the image doesn't match to the code violation. But overall, we have high confidence, so it's worth following up on. Here's an example of a low. So in low, we can see that the picture was taken right after the report, but 3,000 meters away. So my guess is the GPS is miscalibrated. So it could probably be followed up on. Maybe that's my prompt that needs refining. Here's medium. Looks pretty good. They probably took the photo and then followed up later with the report. We're also going to use the 2 sets of coordinates to create a direction, set of directions on Google Maps as well, just because we can. And we can see this discrepancy between the location and the time taken. So someone can go out into the field and see what's going on here. Again, this is probably just a GPS anomaly, but it's helpful to create a picture of what's actually happening with this survey when we compare these 2 sets of information. So, moving on. Oops. Here we go. So here are some of the lessons learned that I found while creating this workflow. Metadata is really messy and overly detailed by default. It's not really made for humans to look at and understand right away. So I would say right off the bat, if you're working with metadata, rename everything to something more descriptive and simplify it wherever possible. Do some rounding. You usually don't need all the information at once. So keep everything you need in the workspace and then remove all the attributes that you don't need. So use the attribute remover to do this because it will get rid of both exposed attributes as well as those hidden attributes. That'll also result in better performance. Clean metadata will also give AI better context and insights. So once you've cleaned everything up, give the AI everything you can. In retrospect, when I look at this workflow again, I would have given my LLM even more of the report details. So it could have caught more of those discrepancies. Maybe I could have given it some information about the sort of GPS anomalies that can happen with devices, and it would have given it a higher confidence score and tossed that report into the high confidence pile to begin with. So we can do some refining on this workflow just by using more of the metadata. Lastly, goes without saying, but metadata isn't always accurate either. It's just another data point, but we can use it to enhance our unstructured data workflows, as well as our AI prompts, like in this example. So all of these examples, like inspections, field notes, compliance reports, AI prompting, come back to the same idea. Valuable metadata is already there. It's just waiting to be used. So if you can tap into it, it can become a real asset when you're working with unstructured data. Okay, so that wraps up our demos. We've seen how to work with unstructured data, PDFs, forms, logs, photos, and turn it into something usable. The key factors here are cleaning, structuring, and taking advantage of all the tools and connectors in FME so that that data can become easier to work with and more reliable. Unstructured data was today's focus, but as you know, FME scales to all data types. This can be structured, spatial, API, streams. We connect all of those together, and it runs anywhere in the cloud, on-prem, or at the edge. And it connects to any AI you choose, so you're ready for whatever comes next. And with that, I will pass it back to you, Elizabeth.
Awesome. Thank you, Sanai. Yeah, just to help us wrap up here today, I want to highlight our global presence. If you are newer to Safe Software, we operate in over 128 countries where we have FME customers across 25,000 organizations. Well, more than actually, that number is probably, I know, growing day by day. And we've been in the game for over 30 years. In terms of resources to help you get started today, following today's webinar, we are all about free resources here at SAFE. Visit our FME Academy, academy.safe.com, for free instructor-led training. And then also our webinar program. I'll highlight, we have just posted a couple new ones, so definitely check those out on our webinar page. And we also have lots of available on demand that you can search by. Next steps to take here today. And before I continue, I know probably have another minute or so left here, but just a reminder, if you do have any questions top of mind that you haven't gotten into the questions tab yet, our live Q&A portion will be after this segment. All right, so next steps. Do get in touch with us. We'd love to chat anything data, info@safe.com. And I'd like to highlight as well our FME Accelerator course. So if you are new or brand new to FME, it's a great place to get started learning the basics. It's 90 minutes free of charge. You don't have to download anything. And I personally found it to be quite a helpful course for learning the basics. And our community badge code. If you're a member of our community, as a thank you for joining us today, we have the badge code on the screen there. I'll also drop it in the chat. And we also have launched a fun little bingo game this month. So if you're curious to take a look, I've also dropped the link for that in the chat, and you can work towards that bingo line with today's webinar as well. Awesome. Okay, so with that, I will prompt our presenters, and Chris, if he wants to join us on the stage here, and we can take a look through the questions together. We did get quite a handful, so thank you everyone for dropping those in as we went along. Looks like we've actually gotten to most of them. So thank you, Chris, for helping with that as well. Is there any team that we might want to start with or highlight? Yeah, it does look like we've gotten to most, which is awesome. If not all.
Yeah, there is one question about object detection within AI. I know we had an old blog on that, so I sent that out, but do we have any webinars, or have we done any webinars recently on that, Elizabeth?
I don't think so, but it's a good suggestion or idea. I'll do a quick search, but I don't think recently anyway.
Anything that stuck out to you, Chris?
Yeah, I think the one main one that came to mind for me is that obviously throughout this webinar, different services, both cloud and local AI services were leveraged. The key thing to note with all of that is we do support all the AI services and have pre-built connectors for a lot of them. So it is really easy to hot swap between those two. So as Sienna and Sanaya will send out those template workspaces, and we have some on the community as well, in addition to some from previous webinars. As you download them, if it's relevant to your use case, but it's not the service used correctly, you can just delete that connector from the workflow and replace it with one that is approved by your IT. So say the example has Google Gemini, but you can only use OpenAI or Azure OpenAI. You can just simply replace that one component of the workspace and use the rest of the workflow. So definitely keep that in mind. When we are building these out, we are trying to be as AI service agnostic as possible. And we do have an article in the community that introduces kind of general authentication for all of these AI services, so that it kind of sets the stage that you can choose and use whatever AI services for any AI related workflows. So yeah, that's just the one thing to keep in mind. The other one is related to, I think it also related to that vision question. There are a number of other vision specific transformers that are available in FME. They don't necessarily have to come from these AI connectors. So I would recommend exploring the quick add menu, so our transformer gallery. And the quick add menu is helpful because it goes through our transformer gallery and the FME hub. That will help you identify a few more vision services that we support. Like obviously Google Gemini has vision, but there's also a Google Vision connector that's built and available in addition to others like Recognition, Azure Computer Vision, and other services like that. So definitely take a look on the quick add menu, just type in the keyword that you're looking for, and there's a good chance there are more services than you think available already.
Awesome. No, just final call to the team. Was there any others you wanted to address? I think we've gotten to them all, though.
Yeah.
I think we've gotten to all of the other ones here.
Awesome. Well, it's a good time to mention that if you do have a question that comes to mind, we will leave things running to the top of the hour. So feel free to still drop it in and we'll keep an eye out on that. But in the meantime, thank you so much, everyone, for your time joining our webinar. And big thank you to Sinai and Sienna for taking the time to prepare and present today's content. And Chris for your support with questions. Thanks so much, everyone, and we hope you have a great rest of your day.
Thanks, everyone.
Thanks. Bye for now.